Assalamualaikum and greetings. Universal Flange for GO-KART engine is our project title for integrated design project. Our supervisor is Dr. DAING Muhammad NAFIZ bin DAING IDRIS. Thanks to Dr. DAING who contribute in stimulating idea and efforts in guiding our team. This is our project team led by Fazrulhasani bin KAMARUZAMAN, and my name is Muhammad TARIQ NAZMEE bin Abdul Rahman, MH19055, and the others members are FALIEQ bin Muhammad HISHAM, ZULIQMAL IZWAN bin ZAKARIA, and DINESH HASAN anak lelaki RAJAN. As for the introduction, the GO-KART is a compact, rapid, light and easy to drive vehicle. The GO-KART has a low ground clearance compared to other cars because it is designed for a flat track racing, yet it does not have a suspension. A GO-KART component car includes the engine, steering, suspension, tires and bumpers. A 2-stroke or 4-stroke engine is used in a GO-KART. However, a GO-KART doesn't possess any suspension, so it is imperative and crucial to control the vibration of the vehicle within a permissible limit to safeguard the essential mounting as well as the physical health of the driver. Apart from that, another major problem with the GO-KART was the starting mechanism. One of the major problems in this existing GO-KART engine was the usage of the pull start mechanism. This system is an old traditional system that used in most small capacity engines. Therefore, in the GO-KART engine, this system is difficult for the drivers or users to start their engines, where it requires more strength and energy for the starting process. So it has been an obstacle for most of the drivers on the track. That is why a new conventional push start system mechanism is needed to overcome this problem. In this work, a design and prototyping of the push start mechanism and universal flange will be performed, which are suitable for all kinds of GO-KART engines. This mechanism could overcome the current problems facing by the GO-KART industries. The objective of this proposal, the first one is to develop a universal flange for the GO-KART engine. The second one, to develop a push start system for 4-stroke GO-KART engine, and to make the starting process of GO-KART engine easier. To replace the pull start system mechanism to push start system mechanism for the GO-KART engine, the universal flange need to be installed as a replacement for the component in the pull start mechanism emerge as a solution. The flange will be designed to be universal and compatible for both 2-stroke and 4-stroke GO-KART engine. The difference between 2-stroke and 4-stroke flywheel. Flywheel in 2-stroke engine, they have a lighter flywheel. That is because the torque fluctuation in 2-stroke is lower than 4-stroke, while 4-stroke requires a heavy flywheel because their torque fluctuation is higher. 2-stroke engine power is produced for every 360-degree crankshaft revolution, while 4-stroke engine power stroke is produced for every 720-degree crankshaft revolution. 2-stroke engine requires a small size flywheel and it keeps a lower energy store because they need energy from flywheel only for 1 stroke, while in 4-stroke, it requires a larger size of flywheel, so it can store a higher energy during power stroke and use the energy at the other 3 strokes. The larger the mass of the flywheel, the higher the energy it can store and give it back. Flywheel material in 2-stroke engine mostly from plastic, so that will make it lighter, while in 4-stroke, the material are high strength steel, so that is why it is heavier. Next, I will pass to Dinesh.
Good day, sir. My name is DINESH HASAN and my matrix ID is MH1070. First, I will start present about our progressive flow of our project, where we will start discussing our project title with our supervisor and our team members. Next, we will find the problem statement of our project and we will have a solution that is our objective of this project. Next, we will have a sketching design for our universal flange, that is for 2-stroke and 4-stroke engine, and an extra component that is adapter for 4-stroke engine. After we have a sketching design, we will do it in our software to finalize our design concept for the fabrication. After we have done our fabrication, if the design is suitable will fit with our flywheel, and our project is successfully achieve our objective. If the design doesn't suit well with the flywheel, and we have to repeat our process from the sketching concept. Next, I will explain about the function of one-way bearing. First, I will talk about the definition, that is to transmit torque between shaft and housing in one direction and to allow free motion in the opposite direction. And here is the video in the slide that I will play now on how it works. When the push start button is pressed, the gear rotates and jams the roller to its end and causing the rotation to the crankshaft to start the engines. Once the engine starts, the one-way bearing locks will be released and to disengage with the gear. And this one-way bearings is used because it has similarity as the pull start mechanism on how it works, where the boat rotates in one direction for the process of the engine to start. Once the engine starts, the one-way bearing will be disengaged from the gear. Now the function of components, where first gear. We will use gear as an act of interface to connect between engine to the starter by using a chain. Next, flange. Flange will be attached from the crankshaft to the one-way bearing for a 2-stroke engine. And for a 4-stroke engine, we need an extra component, that is adapter, to be attached to the crankshaft and flange. Next, this is the first concept design that we have been created for our universal flange. We have created a flat surface universal flange to be attached to the flywheel, but due to the unfitted angle in the flywheel, we've been create a second design that is angle flange in the next slide. Thank you.
Thank you, Dinesh. Hi and Assalamualaikum. My name is FALIEQ bin Muhammad HISHAM and my metric number is MH19059. I will continue with design concept 2 for universal flange. As you can see, there are 3 poles equally distanced between each other. The location of the poles is not on a flat plate. Instead, it is on a plate that was angled to 45 degrees. It was made to increase the strength when the load is applied during operating condition. There are 1 hole in the center to lock at the engine's flywheel bolt and 2 symmetrical holes to lock the rotational force of the flywheel. Next, both design concept 1 and concept 2 has its own pros and cons. Therefore, we made a rate table to choose between the 2 designs. We assess this based on durability, safety, material cost, manufacture cost, simplicity, and universality. In this rating, design concept 1 has achieved a net score of -3, while concept design 2 achieved a net score of 3. With this result, we concluded to continue with concept design 2. Based on our observation, concept design 2 has stronger durability, better safety, and the angled flange will give more clearance. Now, we will proceed to concept design for the adapter. For concept design 1, it consists of 4 parts, which is a flat plate in the middle, an outer threaded pole at the top center for locking the flange to the adapter, 2 symmetrical poles to lock the rotational force when the flywheel spins, and an inner threaded pole at the bottom to lock at the engine's flywheel bolt. Now, I will pass to ZULIQMAL to continue with concept design 2 for adapter. Thank you.
Assalamualaikum. My name is ZULIQMAL bin ZAKARIA, MH19068. I will continue FALIEQ presentation. I will present about the concept design 2 adapter. The second concept design was created using the angle of the flywheel and the flange. Without any modification, this adapter manually attached to the crankshaft nut. With the flange on the top of the adapter, it is able to sustain the engine's rotating speed. Finally, this flange is simple to put up and take apart. Next, I will present to you concept screening adapter concept rate. As you can see, design 2 is more durable since it can endure the engine spinning speed, but design 1 is preferable in terms of safety because it should be able to fit the flange and flywheel without any modification. The material and the manufacturing cost for design 1 are nevertheless greater than for design 2. Finally, design 1 simplicity is more complicated than design 2. So we will continue to use design 2. So this is final concept design adapter. We have chosen concept design 2 because it is lower material cost, lower manufacturing cost, and better overall mark rating. I will present to you the analysis for flange. The maximum safety factor is 15 microliter at the flange outer diameter and the minimum safety factor is 10.48 microliter at the pulse outer diameter. The mill steel safety factor is 0.275 microliter while the standard steel safety factor is 0.3 microliter. We can see from the safety factor analysis that the material and design are both safe and that the safety factor range much below the failure threshold. When employing yield strength, the safety factor may be computed as the ratio of the highest permitted stress to the equivalent stress one misses. It must be more than 1 in order for the design to be considered acceptable. If the number is less than 1, there is some persistent deformity. To summarize, the material utilized and the flange design are both safe. Thank you. I will pass to the Fazrulhasani.
Hi and Assalamualaikum. My name is Fazrulhasani bin KAMARUZAMAN, metric number MH19058. Thank you to ZULIQMAL IZWAN for explanation about analysis safety factor for universal flange. Now, I will continue to present my part, which is analysis of safety factor for the adapter. As you can see, the picture shows the isometric and top view of the adapter part. Through the observation, the picture shows that the maximum safety factor is 9.005 power of 4 microliter at the rear outside diameter of the adapter. Since the material used is mild steel, so the material and the design are safe to be used. Furthermore, the range of safety factor are far from failure. As the result, the adapter is appropriate to use. Next, I will continue to explain about the advantage and disadvantage of concept designs that our group choose. The advantage of the concept design are universal to all go-kart engine, which is 2-stroke or 4-stroke. If the go-kart use the 2-stroke engine, so it will use universal flange, and if 4-stroke engine, it will need an adapter as addition part. Second is sufficient space to fit in flywheel. The universal flange and adapter concept designs are measured based on the dimensions flywheel, so that it will fit to the flywheel and casing cover. Lastly, easy to assemble. The adapter is designed to attach on the flywheel while universal flange on top the adapter. The disadvantage of this concept design is hard to fabricate. It is because universal flange have angles that we need to follow. If not, it cannot be fit to the flywheel space. Second, increase in engine weight. With addition part of universal flange and adapter, it will increase the engine weight. Now, the slide shows us a Gantt chart. During this semester, we were given the task to design a project that is a universal flange for go-kart engine. We start our week with project briefing, group selection, title selection, discussion with supervisor, group discussions, and midterm presentation for first half of semester from week 1 to week 7. The second half of semester, we are continue to do the conceptual design and analysis, prepare the presentation slideshow, and report. Now, we are at the end of my presentation. As conclusion, the objectives and scope that have been discussed, we have decided to develop a universal flange for go-kart engine. It is because these projects are intended for the go-kart industry. This project also aims to solve the problem of go-karts having difficulties starting their engine, and it can be utilized to benefit the go-kart business. For this semester, we are going in with the literature review and analysis for this project. And for the expected outcome for integrated design project 2, we are make the starting process of go-karting easier, successfully made the design universal flange and adapter, and successfully change the starting mechanism, which are from the push start system to the push start system.